Hey, and thanks for joining me here in Chicago. My name is Beacraft. I'm the Vice President of Digital Strategy and Innovation at Hawkeye Agency. And today I'm going to be talking about social media and the future of social media. And I'm incredibly excited to be talking about this subject, but I wanted to do something a little bit different than your typical keynote, especially in a virtual setting. Those are typically slides and a little bit of webcam. And given the subject, I wanted to do something that represented the type of technology we'll be talking about. So I hope you enjoy this. This is a new experiment for me, and I'll see you in the video. To explore the future of social media, we have to address its past. Over the past 2 decades, a lot has happened. In fact, it was just 4 years ago that Facebook added video to the newsfeed. I can barely remember a network without it. And the technology of the last 2 decades of social media networks has been built around understanding the users on its platform, from their preferences to the places they've been, the people in their network, the things they've eaten, all to understand how to create a curated algorithmic experience on their platform, from selling targeted ads to personalized products and some basic experiences. But the technology that's defined this era of social media are things like the smartphone, 4G and walled gardens. The smartphone made social media immediate and contextually relevant to what you're doing in the moment, and took it away from the tether of being a desktop activity. 4G allowed us to watch video and play with immersive content in real time. And walled gardens defined our relationship with these social media networks. But the technology of the next 10 years won't be defined just around understanding the user and their attributes, but understanding the physical world around them and understanding every detail of the context in which they live in it. The technology that will define this era of social media computing are things like machine vision and artificial intelligence, the Internet of Things, IoT and blockchain, and the convergence of these technologies will create the infrastructure upon which the next era of social media platforms is built. And it's these technologies that we'll talk about as we go future forward and discuss the evolution of social media.
And there's no better place to start than with what Facebook is doing with visual commerce.
We're building AI systems to not only make it easier to buy and sell things online, we're engineering something entirely new. Imagine this. You've moved into a new place and you realize you need a little more light. An AI lifestyle assistant can analyze your furniture and recommend the perfect mid-century lamp to complement your decor. You can then try it out virtually and even share photos with your friends to see what they think. Plus, when it's time to declutter, the AI assistant can help you sell things by categorizing and describing items in any language. Facebook AI is one step closer to making this happen. All of this starts with building models that can both recognize products and images and understand your personal style to tailor recommendations just for you. We've been building techniques to achieve clothing segmentation, which labels each pixel in an outfit image with its clothing type. Clothing is especially challenging for AI to identify because bodies have many shapes and clothing can take on a wide range of appearances. Plus, clothing is often layered or hidden behind hair. This kind of complexity is really common in Facebook photos. Our segmentation technology will help unlock experiences that were previously impossible. For example, we're building a system that can look at a picture of your outfit, segment each piece of clothing that you're wearing, and ingest them all into a digital closet.
Hold up. Remember at the beginning how I said that social networks are now trying to understand the physical world that you inhabit? This is just one way that they'd be able to do it, by providing a service like this. If you've tried other products like Pinterest Lens, Google Lens, or even Amazon Style Snap, you've probably seen that they come close, but they're not very precise. For example, you might take a picture of a pink polka dot blouse and instead get a product of a pink polka dot t-shirt back. It's close, but it's not really what you wanted. With the Facebook concept, you wouldn't only get closer to what you're looking at, you'd also have the context of your entire library of clothes to work with. So by adding that context, there's all sorts of things you can do with that. And it's not just for fashion, as you'll see next.
I'm excited to show you how our latest product recognition system works. Some models might work well in fashion, and others in home decor, but a truly scalable system needs one model that can correctly identify millions of products across all fine-grained categories. We use weekly supervised learning, where a model is arranged in a feedback loop to automatically create additional training data. So here's an example of an application. Say someone lists a rug for sale, but they didn't describe it well, or they speak a different language than their potential buyer. All you have to do is take a picture. Our model automatically fills out the metadata across fine-grained product categories. With our predictions, we're able to recognize 90% of carbon material attributes for home and garden products, up from 33% just a few months ago.
Launching with a generalized algorithm like that would be a big deal to the Facebook platform. In the past, if you wanted to use machine vision to understand what products you have in front of you, you'd likely have to use an app specific to a retailer or vertical. Retailers will build out apps like this for auto parts or fashion or home decor, but they don't often span an entire line of products or all different fields of products. With Facebook being able to recognize all sorts of products regardless of that vertical, they can change the game in terms of e-commerce marketplaces, and even do so for their Facebook marketplace. If you've used that, you probably have seen that it's basically a fancy version of Craigslist and not quite as nice as eBay. But with something like this, they'll be able to steal business from places like that and even become a powerful marketplace for other first-party sellers. If we're going to talk about the evolution of algorithms, we need to address digital beings, or synthetic humans. Now, we may be generations away at best from artificial general intelligence, but that hasn't stopped some companies from creating incredibly lifelike synthetic beings. I am the only human on this set. They are not real. They are computationally generated in real time. In translation, they're completely artificial. This brings incredible opportunities for brands to create really organic experiences. If you combine algorithms that understand the world around you with a vast programmed understanding of the brand and apply conversational design principles often used in chatbots, you can have a very organic experience with a brand representative. This is far more than what you could have with the chatbots of today, which are often no more than glorified FAQs. So how do brands take advantage of this? Well, designing for visual and conversational commerce is a slight bit different than your standard web and social media experience today. Understanding how conversations are built through platforms like Google's Assistant and Alexa will help you a lot, but also looking at natural situations like when a customer talks to an associate about a product or has a question. Understanding those types of exchanges will help you design natural conversations for assistants like the ones you just saw. Understanding how to design for visual commerce is slightly different. That's all about the metadata that algorithms will look at for your products. Everything from the places that your product shows up in imagery, where your logo is placed in different contexts, and also what metadata shows up on the assets that find their way to the web and social platforms. Understanding your metadata and also understanding where your logo shows up will help you understand how the algorithms are likely to see your product and classify it. This will help you understand how it's likely to be shown and served up when visual commerce takes place. So knowing this will help you control where your product shows up and how it shows up in these types of places, instead of leading that just to Facebook or Google. While visual commerce is about helping machines understand the real world so that you can shop it via digital platforms, spatial computing takes that to a whole nother level. Spatial computing enables machines to understand the entire physical world around you and the relationships of the objects inside of it, essentially turning the entire world into a machine-readable object. Rather than just understanding what an object is so it can classify it, the algorithms can understand the nature of the object itself. How does it relate to the user? How does it interact with the user? What's its function? And also, how does it work in physical space? This type of information can help these types of algorithms create all sorts of experiences with that object, but also understand how all these objects relate. We're seeing some very basic functionality built around this right now on platforms like Magic Leap and HoloLens, and some examples to see very limited functionality on things like Spatial I/O, which is a remote collaboration platform. Incredibly robust as it is, it's one way of seeing a very limited set of capabilities of what spatial computing's full potential really is. So let's take a look at some of the components that have had massive advancements in the last few years that'll enable the next generation of spatial computing. One example here is with the iPad Pro using its LiDAR to understand the environment around it. As we talked about earlier, understanding not only what the objects are, but how they react is a key component of spatial computing. And in this case, we're seeing this application understand the objects in the room, but also understanding the space between them and how their materials will react to different types of interactions. Now, as we see the balls starting to enter the room, they're also bouncing off of these surfaces. For the couch, you can see that it has some spring, and the table, it's also bouncing off those objects in a specific way. And if it hits the wall, it's bouncing off of multiple surfaces. This is showing that these machine vision algorithms have an understanding of the objects themselves, but also some understanding of the context in which they're actually being used. Pretty impressive so far. But let's say we want to take this to the next level and not just understand a room, but understand large spaces. This example from 6D AI is using 4 phones at the same time to map a large space and crowdsource that space, and then stitch those images together to create one complete map of that space. It's essentially like Google Maps for indoors. And if you can see this happening millions of times over, it won't be too long before most places indoors can have their spaces mapped. And it won't just stop there. Remember I talked about LiDAR a moment ago. High-end LiDAR can help us create incredibly detailed replicas of environments. In this case, you can see a very detailed location in Tokyo. It's almost impossible to tell the difference between this and the actual location. And this is using an understanding of the environment by pinging lasers off the environment itself and then stitching that data back together into one composite. But it's not enough just to look at the objects and the space around us. We need to be able to tie this together on a global scale if we're going to be able to create immersive environments and augmented and spatially computed environments at large scale. So we also need to understand cities, states, and countries in 3D data. One company, Sturfy, is doing just that by using satellites to create photogrammetric understandings and 3D models of cities. It's essentially taking pictures from those satellites and then creating this 3D knowledge so that it can then be used to create these experiences and understanding where different things happen within this space. From understanding where the local services are, like your ride hailing, or even local landmarks, or even posting advertising data on different services. By using this metadata, we can then create all sorts of canvases on the world around us. And it's not just humans that will be using this data. In fact, we can create synthetic environments to train machines. In this case, we're looking at Lexset, which is creating a synthetic environment to train a machine learning algorithm. All of these images are computer generated, and the machine vision algorithm is learning what these different objects are and how they're used. What this allows us to do is train a machine vision algorithm millions of times in a short period of time, just by using that same synthetic environment over and over and over again, rather than relying on real-world training, in which case some of this training would take hundreds of years. Instead, we can take and compress that training into an incredibly short period of time. We can then use that data to put it into all sorts of use cases. In this case, we're looking at Microsoft's AirSim. And this drone is an autonomous drone that's trained to do all sorts of tasks, like power line inspection, and even help find and search and rescue. These things are only possible because artificial simulations have taken place millions of times, and that data has helped these algorithms understand how to perform specific tasks. An extension of visual commerce is what some call 3D commerce, which is really just a way of saying building your assets in 3D. Now, instead of going to photo studios and shooting your product there, a lot of what you're seeing in product shots and e-commerce these days are 3D renderings of those products. And this is becoming more and more popular with brands from automotive to consumer packaged goods. And as we start to move to mediums that are more immersive, like augmented reality and virtual reality, this becomes more important to build your assets in 3D rather than 2D. That way, the brands can have a presence in those spaces. One brand that's done this incredibly well is Wayfair. Since 2016, they've had a 3D model API that developers can use to access thousands of models of their furniture. And you can even download them from sources like Sketchfab to put in 3D scenes. Now let's go ahead and play with some of those models. In the scene we've got here, I want to add a little more style to it. Let's start with something like a floor lamp. Scroll through a couple of models they have here. I like that. Now let's add, let's say, some extra lighting from the ceiling. That looks good. Okay, we need a little more space for people to hang out, so we're going to add a chair to the side of the couch. That feels right. Now I've got a space that I can work with. And I can even use this as a 3D space to immerse myself in, and I might even be able to turn this into a virtual reality experience. So, more and more content will be built for immersive experiences, and brands like Wayfair that are making their assets available to everyone will be almost ubiquitous. And in fact, they'll be turning other brands into third-party resellers for their own products. Let's say I encounter some of these chairs in a video game, I might even be able to purchase those products from that space. One brand that's been doing that for years is Nike, with Nike ID and the NBA 2K games. You can buy your own Nike ID shoes from the shoes you create inside the game. We're likely to see a lot more stuff like that as commerce becomes available in almost any medium. And finally, let's talk about the tools that will make these experiences possible, but also some of the tools that this new technology will also enable. Let's start with something like this. Augmented reality design. In this situation, we're seeing machine vision understand the world around it to create a connection between the smartphone camera and the document being designed on a laptop. Rather than having to connect these physically or send one from another, it's actually understanding what's in front of it and putting it directly into the object and document there. This is just a prototype right now, designed by one developer. So it's in beta, but I have to guess that Adobe's got a keen eye on something like this. Next, let's talk about LiDAR, and LiDAR on mobile devices. Earlier, I showed you a clip of the iPad Pro starting to understand the room around it. This was one of the most major developments in new feature sets on mobile devices in the last several years, and it was released without a whole lot of news. That said, as more and more devices get a LiDAR built into them, as they will with the next launch of the Pro iPhone, Apple will start to be able to map all sorts of information about the world around us. Think of Waze and how they source traffic data by using consumers to crowdsource that information. Well, now apply that to LiDAR data to understand specific objects, rooms, locations, depth, and sensing information, all from your mobile device. Doing that millions of times over in millions of different locations. That is powerful. That will create incredibly large and robust understanding for machines to be able to understand all sorts of objects and create experiences with those. And then there's simulation programs, oftentimes used for things like video game design. Now they're expanding to everything to reality simulation and even Hollywood. Unreal Engine and Unity are probably the two biggest applications in this space, just like we saw with the Microsoft AirSim earlier. Unreal Engine in particular has created a virtual production environment that's being used all over the world to recreate environments without having to actually build those sets or go on location. In this particular example, you can see someone walking through green screen space and sitting on chairs, but the actual production looks like they're in a real house. You can't tell the difference. With this type of technology, you'll also be able to insert all sorts of 3D environments and 3D objects, harkening back to a lot of the content I've talked about before. As more and more experiences are designed in applications like this, having 3D assets available from your brand allows you to be present in these spaces. Next, these types of programs also enable VR creation. Some companies are relying on virtual reality to both create and test products. Here we see Bell Helicopter, and they're actually bringing a pilot into the cockpit of a virtually designed helicopter. Rather than having to build this particular product and then test it in the real world, they're able to do so in virtual reality and ask the pilot what type of changes they would make. How are the ergonomics of the cockpit? Where would you place things to have the access that you need? And as a result, they were able to take a process that typically takes 5 years and shave it down to 6 months, saving them tens of millions of dollars in the process. This is the power of virtual capability. And it doesn't just stop here. More and more of Hollywood is using this. In fact, all of The Mandalorian was shot using virtual production. So how do brands take advantage of this capability? Well, let's take a look at one brand that's doing an exceptional job. Mercedes recently did their entire Masters Tour commercial in virtual reality. And in this case, none of the production crew was in the same room with anyone else. They were all dispersed in remote locations. Using virtual reality, they were able to emulate all sorts of different cameras, lenses, focal lengths, and other cinematic tricks. In fact, they were able to do things in virtual reality that they couldn't have done with real physical equipment being on set. Different types of camera moves that weren't possible before. By being able to do this, they generated an entire commercial in 3D from start to finish without having to be in the same room or on a set. This is an incredibly powerful tool for the future of cinematic experience and for commercial design. But it doesn't just have to stop there. It can be used for all sorts of experience. So, going forward, you may not have Mercedes kind of money, but these types of experiences will become more and more mainstream, the tool sets more accessible, and the talent in bigger supply. So I highly encourage you to start investigating what it will take for you to invest in things like virtual production or 3D design, because 3D is going to be even more essential in the future of production than it ever has before. It's a wise investment, and I highly recommend it. Thank you for spending some time with me today. I really appreciate you coming with me all the way from the very beginning of the evolution of social media to some of the examples of the technology that's going to empower the next generation of the platforms, all the way to the tools that will help you make these experiences. I hope you've learned something today. I hope you're inspired to go out and work with some of these tools and become part of creating that future yourself. I'm Ian Beacraft. Once again, thank you so much for joining me, and I hope to see you soon in the comments and questions.